Alright, today we're going to talk about Unit 4 Lesson 5, which is the gas giant planets. Previously we've talked about the terrestrial planets, which are the inner planets, Mercury, Venus, Earth, and Mars. Now we're going to talk about the outer planets. 6.2.4 is your state standard for this lesson. A giant among us. What is a gas giant planet? The four gas giants are Jupiter, Saturn, Uranus, and Neptune. A gas giant is a planet that has a deep, massive gas atmosphere made up mostly of hydrogen and helium, and there's no surface to physically stand on. So if you were to be able to go there, which would be extremely difficult, you would not be able to actually get out and stand on the surface of the planet. The gas giant planets are very large and very cold. Again, very hard for us to understand how cold a gas giant really is. Remember, they're much farther away from us, away from the sun than even we are, and it's very cold on our planet at times. Let's start with Jupiter. Jupiter is the largest planet in the solar system. Its mass is actually twice that of all the other planets combined. So if you would add up the mass of all the other the planets, and then double that, Jupiter's mass would still be larger. It also has the highest surface gravity in the entire solar system, which means, remember, weight is determined by how much gravity pulls on your mass. So what you weigh on Earth, if you were able to go to Jupiter, the gravity there would be pulling on your mass even more, so your weight would be higher. Although all the gas giant planets rotate very quickly, Jupiter is actually the fastest of all of them. Its period of rotation, meaning how long it takes for it to experience day and night, would be just under 10 hours. Remember, it takes Earth 24 hours and 56 minutes, and it takes Venus over 200 days. So very different. Jupiter is going much faster. The winds on Jupiter can be as fast as 540 kilometers an hour, and the clouds are stretched into bands that run from east to west. And storms appear as white or red spots between the cloud bands. The best known of these storms is called the Great Red Spot, and we can actually see it through telescope imagery that astronomers have. They can see the Great Red Spot. More than 60 moons actually orbit Jupiter. So remember, the natural satellite to the Earth is our moon, and Jupiter actually has 60 natural satellites. More than 60. The best known of them, the largest ones, are Io, Europa, Callisto, and Ganymede. These are the largest moons of Jupiter. Io is the most volcanically active place in the entire solar system. It has at least 400 active volcanoes that are ejecting lava and geysers of sulfur compounds. So very smelly. Remember, sulfur kind of has the rotten egg smell. Let's go to Saturn, king of the rings. Saturn is the second largest gas giant in the planet, and it's also made mostly of hydrogen and helium. Saturn's average density is less than that of water. Remember, the density of water is 1 gram per milliliter, so the average density of Saturn is less than 1 gram per milliliter. Saturn's most spectacular feature is its planetary ring system that encircles the entire planet's equator. A rather large and extensive planetary ring system. A planetary ring system, is a disk of material that circles a planet and consists of orbiting particles. So these are materials, could be rock, could be chunks of ice, could be large dust particles. They're encircling the planet, going around and around the planet and orbiting as particles. Saturn's ring system has many individual rings that form complex bands. Between the bands are gaps that may be occupied by moons. So in between the bands, some moons may occupy that space. Saturn's rings are nearly 500,000 kilometers in diameter, but they're only a few kilometers thick. So only 500,000 kilometers in diameter. They are 500,000 kilometers in diameter. That's pretty big, but only a few kilometers thick, so rather thin. The rings are mostly pieces left over from the collision of Saturn's moons with comets and asteroids, so those particles were kind of broken up and now are orbiting Saturn. Saturn's moon Enceladus has an icy surface. The liquid water flows up through the cracks in the surface and freezes, or forms spectacular geysers. Geysers are like eruptions of water with other compounds in it. Think of like Old Faithful at Yellowstone, if you've ever seen that. That's a large geyser. Titan, Saturn's largest moon, has an atmosphere made up mostly of nitrogen, but we've also found traces of methane and ethane in the atmosphere of Titan, Saturn's moon. Titan has a crust of ice with lakes and ponds filled mostly with liquid methane, so very interesting finds on a moon. Let's look at Uranus, just rolling along. The atmosphere of Uranus is composed mostly of hydrogen and helium. Again, that's what makes it a gas giant. But it also has some methane that's been found in the atmosphere. The methane absorbs red light, which gives this planet a bluish-green color. How is Uranus unique? Uranus is unique because of its axis of rotation. It's actually tilted almost 98 degrees, which means that the planet is tilted on its side as it orbits the sun. So if you look at Earth, here, look at our angle, we're a 23.5 degree angle. But Saturn is 98 degree angle, so its axis actually goes through this way, where Earth's axis is going through this way. So it's actually rotating on its side as it goes around the sun. A blue windy giant, this is Neptune. Neptune is the most distant planet from the sun. The sunlight on Neptune is 900 times fainter than the sunlight on Earth, so very much less direct sunlight on Neptune. High noon at Neptune may look like twilight on Earth. So imagine the most sunny time on Earth, high noon, looks just like twilight, like maybe just before dusk on Neptune. In 1989, Voyager 2 actually revealed a huge dark area in Neptune's atmosphere, and this storm was named the Great Dark Spot. So this huge dark area was discovered to be a storm. In 1994, the Hubble Space Telescope found no trace of this storm, but other spots that may grow larger with time have been sighted. So a very interesting find. 89, we find this large spot, and then 94, a few years later, it's gone. The energy that powers the strong winds in such storms may come from Neptune's warm interior, so the center of Neptune. And it does have very powerful winds on Neptune. Okay, the last thing I want you to do today is page 216. I want you to do numbers 16, 17, 18, 19, and give 20 a try for me. Thank you. Don't forget to fill out a visa. Get that signature. Have it ready for class tomorrow.